Hello everyone, in today's video I'm going to solve this problem. So this problem is related to Bernoulli's equation of fluid flow. So first read the problem. A pipe 300 meters long, 300 meters long, a pipe has a slope of 1 in 100. স্লপটা হলো কত 1 in 100 এখান থেকে এখানে যে স্লপটা সেই স্লপের যে মানটা সেটা দেওয়া আছে 1 in 100 and tapers from 1 meter dia 1 meter dia থেকে এই ডায়াটা কত হয়েছে at the higher end 1 meter dia থেকে সেটা হয়েছে into 2 a 0.5 meter at the lower end. The quantity of water flowing in is 900 liters per second, and then the quantity of water, that means the discharge. Here the discharge is 900 liters per second. That means here the discharge, and the discharge here q1 is equal q2 is 900 liters per second. If the pressure at the higher end is 70 kilopascal, here the pressure is 70 kilopascal. Find the pressure at the lower end. Find the pressure at the lower end. P2 is equal to what? So here is a datum line. So q1 is equal to q2 is equal 900 liters per second, 0 or 0.9 meter cube per second. So d1 is given 1 meter, so we can easily find out a1 pi by 4 d1 square. Here is the pipe section. The area of the pipe, cross section of the pipe is pi r square, then the r is d by 2. Then we can we get, and the value of a1 is pi by 4 d1 square. Then just put the value and easily solve this. And we know discharge q is equal a1 v1, discharge equal qv, q is equal to av, sorry. Then v is equal q by a1, then v is v1 is equal to q by a1. So q, the value of q is 0.9 and a1 value is 0.785. Then the value of v1 velocity at the higher end section is 1.146 meter per second. Then h1 is 3 meter. Here the slope is given 1 in 100, and the length is 300. So 300 by 100 is 300 is divided by 100 is h1 is 3 meter, and h2 is equal 0 meter. Here the datum line is passing to the lower end of the pipe. So h2 is equal to 0, and rho and g is we know that for water density is 1000 kg per meter cube, and the gravitational gravity due to acceleration due to gravity is 9.81 meter per second square. And d2, here d2 is 0.5 meter, then we can find out a2 is pi by 4 into 0.5 square. Then a2 is then q2 is equal to a2 v2, then v2 is equal to q2 by a2. The q2 value is the same value here, 0.9, and a2 is 0.196, and v2 is 4.591 meter per second. h2 is equal to, here h2 is equal to 0. The datum line is passing to the lower end, and p2 is equal to what? We need to find out the value of p2, pressure at the lower end. From the Bernoulli's equation we know p1 plus rho gh1 plus half rho v1 square is equal, this equation we know. Then just put the value of the given data, then we can easily get the value of p2 from here. So pt is 89,544.178 pascal, and then kilopascal, just divided by 1000. Very simple. I hope you understand. Let's see another math. So here a pipe 5 meter long is inclined at an angle of 15 degree with the horizontal. The smaller section of the pipe, which is at a lower level, is of 80 millimeter dia, and the larger section of the pipe is of 240 millimeter dia as shown in figure. So this figure is also given in this problem. So the lower end is dia is 80 millimeter, and the higher end is the dia of the pipe is 240 millimeter, and the pipe length is 5 meter, and the angle between the datum and the pipe is given 15 degree. The inclined at the angle of 15 degree with the horizontal. So and again determine the difference of the pressure difference. Here the pressure, and here also the pressure. This pressure difference we need to find out this value. Two sections. If the pipe is uniformly tapering and the velocity of water at the smaller section is 1 meter per second. Smaller section in here is the velocity is given 1 meter per second. So from this d1, the smaller end d1, and here is d2, section 1 section 2. If we assume this, then d1 is equal 80 millimeter or 0.08 millimeter. Then the value of a, that the reason is the pipe, the area is pi r square. Then we easily find out this value a1. Then v1 is given 1 meter per second. Q is equal to av, we know. Then from here we can find out q1. Q1 and q2 is the same for the continuity equation, we know that. So and then q1 equal to q2 is equal to a2 v2. Here d2 is given 240 millimeter, 240 millimeters. So 240 millimeter or 0.024 meter. Here the a2 we can find out this value 45.23 into 10 inverse 3 meter square. Then v2 is also we can find out q1 by a2. Then v2 is equal 0.111 meter per second. And here is the another term. Okay, here we see the datum line is passing to the lower end. So the h1 is equal 0, but the h2 have a value. So this value we need to find out. We see that there is angle is 15 degree. So this angle this datum line is if we assume the datum line is ভূমি, এটা যদি ভূমি হয়, ঠিক আছে, এটা হলো আমাদের কি, এটা হলো আমাদের লম্ব, আর এটা হলো অতিভুজ। তাহলে অতিভুজের মান আমাদের কত দেওয়া আছে, 5 মিটার। সেই অতিভুজটা আমাদের 5 মিটার, এবং এখান থেকে এই ভ্যালুটা আমাদের বের করতে হবে, অর্থাৎ এটা h2 এর এই মানটা আমাদের দরকার, ঠিক আছে। h2 এর এই মানটা আমাদের দরকার। তাহলে এখান থেকে আমরা দেখতেছি এটা অতিভুজ, এটা হলো লম্ব, তাহলে লম্ব অতিভুজ থিটা, এটার কোনটার সাথে সম্পর্কিত আমরা জানি সাইন থিটা। সাইন থিটা ইজ ইকুয়াল লম্ব ভাগ অতিভুজ। তাহলে সাইন থিটা ইজ ইকুয়াল টু h2 বাই 5, অর্থাৎ সাইন থিটা, সাইন 15 ডিগ্রি ইজ ইকুয়াল টু h2 by 5. Then we can find out h2 value. And then for the both section rho is 1000 kg per meter cube, and z is 9.81 meter per second square. From Bernoulli's equation we know that this equation, and just p1 minus p2 এপাশ থেকে এপাশে লেখলাম। এরপরে এটা জাস্ট সিম্পলিফাই করে নিলে ইকুয়েশন জাস্ট সহজে ভ্যালুগুলো বসা দিলে এটা সহজে আমরা পেয়ে যাই 12.2 kilopascal. Very much easy. So the pressure difference between these two sections is 12.2 kilopascal. Hope you understand. Thank you very much. If you do not understand anywhere of this problem, you can comment below the section. Okay, bye, see you.